In this video, we are going to look at finishing up that derivatives worksheet. With problem 15, it says if f of x is x cubed minus x minus 7 to the fourth power, find the derivative and simplify. So we have a product rule here. But also, when we take the derivative of this second term, we're going to have to use we're kind of going to have to use the chain rule because we have something being taken to the fourth power and then an inside function. So let's see how that impacts the problem. For our derivative, using the product rule, let's identify these. Here's my first expression, and here's my second expression. So we'll take the first, x cubed, times the derivative of the second, which is 4 times x minus 7. And then that would be to the third power. Then the derivative of x minus 7 is just 1. So the consequences of our chain rule are minimal. So this is the first times the derivative of the second. And we have to do plus the second, which is that x minus 7 to the fourth, times the derivative of the first, which would be 3x squared. Now, we can't distribute any of these things into these parentheses because these parentheses are being taken to the third power. So let's see if we can clean this up a little bit. I'd probably write 4x cubed first, and then the x minus 7 cubed. And here I'd probably write just 3x squared times the x minus 7 to the fourth. And that is good enough for simplifying. We don't want, to multiply this out, we'd have to take x minus 7 times x minus 7 times x minus 7, and we don't want to do that. It looks simpler as it is. Now, for part B, however, where we have to find where the tangent is horizontal, a tangent line is going to be horizontal, we know, when the slope is 0. And since derivatives represent slopes, what we need to do is set our derivative equal to 0. Setting this equal to 0, we're not going to be able to solve it unless we factor it. So as I look at this first answer here, I can see, so I have this first term in green and this second term in green. They're separated by the plus, but they are a product, each one of them. Within them, they both have x's. Maybe I should make that a different color. And they both have x minus 7 to the x minus 7s to a certain power. So what we're going to do is this has an x cubed and this has an x squared. That means I can factor out an x squared. This has an x minus 7 to the third, and this term has an x minus 7 to the fourth. That means I can factor out an x minus 7 to the third. Now, once we do that, we have to put what's left inside the parentheses. So for my first term, I factored out an x squared. If you divide x cubed by x squared, you just have one x left. So my first term would have that 4x. Now I also, from this first term in green, factored out my x minus 7 cubed. So it's no longer there. We divided it out. Now we go to our second term in green here. So it's plus, the 3 stayed there. And I did factor out this x squared. It's gone. It's out front here. So I no longer write it inside the parentheses. But then from this x minus 7 to the fourth, I factored out a power of 3 of them, which means one of them remains, like that. So this will be the process that will enable us to solve this, setting it equal to 0. Simplifying this, we get 0 equals x squared times x minus 7 cubed. And then the 4x, and this will become a 3x, will give us 7x. And 3 times a negative 7 will give me a negative 21. So now we can solve this using the zero product rule, which states that if you have things that are being multiplied together and the answer is 0, then either one of them at least has to equal 0. This one, that one, or that one. So since x squared times x minus 7 cubed times 7x minus 21 being multiplied gives me an answer 0, we say, well, that means that either x squared equals 0, the x minus 7 equals 0, we don't have to worry about the cube, or the 7x minus 21 equals 0. Solving this, we get x equals 0. If we add 7 to both sides here, we get x equals 7. And if we subtract the 21 here, we get 7x, or I'm sorry, if we add 21 to both sides, we get 7x equals 21. Excuse me, 21. Dividing by 7, we'll get x equals 3. So these are the 3 locations where the tangent line is horizontal because the slope equals 0. We're going to do problem 16 similarly. Whoops. Problem 16 says, find the derivative of f of x and simplify. Before we do that here, the way we know how to take the derivative of a square root is to turn that into a fractional exponent. So we're going to rewrite this equation as x squared minus 8x plus 20 to the 1/2 power. Now, taking the derivative, of course, will involve the chain rule because we have our outside function being taken to the 1/2 and our inside function as that trinomial. So our derivative will look like this. And we'll have 1/2 times the x squared minus 8x plus 20. And now that we've done that, we have to subtract 1 from our exponent, which will give us a negative 1/2. Now we take the derivative of the inside function, where we'll get 2x minus 8. Cleaning this up, this 2 will go in the denominator because it's in the bottom of the fraction. This x squared minus 8x minus 20 is really a negative exponent, so it will go in the denominator. And this 2x minus 8 will go in the numerator. So our answer will look like this. The 2x minus 8 over the 2 times the x squared minus 8x plus 20. Now it's to the positive 1/2. We've moved it into the denominator. I notice both of the numerator terms are divisible by 2. So if we factor that out, oops. Do we factor a 2 out of 2x minus 8? We'll have 2 times x minus 4 over 2 times x squared minus 8x plus 20 to the 1/2. And these 2's can cancel in place. So now we're going to set, so now our final answer is x minus 4 over x squared minus 8x plus 20 to the 1/2. All right. The second part says find the value of x where the tangent line is horizontal. Once again, we remember our rule. The tangent line is going to be horizontal when the slope of that tangent line is 0, which will be when the derivative equals 0. So we set this equal to 0, this derivative. The way we solve fractions is we multiply both sides by the denominator. My denominator here is x squared minus 8x plus 20 to the 1/2. So I'll multiply this side by that too. Now 0 times anything is still 0. And this will cancel with the denominator here. So we have 0 equals x minus 4. Solving this, we'll move the 4 over and we find that x equals 4 is where we have a horizontal tangent. All right, I hope that was helpful. Thanks for watching.